Hey everyone, we are Terodata BrainBuilders actually. We combine teams, as you can see by the number of people on this slide, because, well, this problem's hard, and more brains, more fun. So, the problem we're working on, some people talked about it before. We were working on the BrainBuilder problem, and it kind of breaks down into two components. One, as you can see on the left side, we want to find the brain. In that CT scan image, every skull that the museum curates, it takes 100 hours to scan and identify where the brain is. There's around 500 to even 1,000 images per brain. So if we can automate that process, that would be a great help. And then the second thing we worked on was, can we render those 500 to 1,000 CT scan images into a 3D rendering over there? And can we see it? That's our rendering, so yes, we can. All right, so let's take a look at some of our results. So on the left, you can see what we've identified as the brain. And on the right, we can see the original CT scan image. That outline over there you can see in the brain is where the brain is, and that's where we've identified where the brain is. So we've found it. The way we did it was we did a bit of filtering, denoising, a little bit of segmenting, and a lot of monkeying. So if you have no idea what those terms mean, neither do we. We are not computer vision experts. There's quite a bit of monkeying and tweaking until we get the parameters just right. What happens, though, is unfortunately this algorithm kind of starts to break down at the very extremes of the brain. So at the very top and the very bottom, where the brain starts to kind of shift from what the middle of the brain and most of the brain looks like. And also, bird brains are easy. Dino brains are very hard to do this with. That's because of all the sentiment, and also because there's a lot less contrast in those images. Wes is going to take us through exactly how we did this.
Thanks. So you can see here a couple of images. That's the original CT scan, and we ran the thing through a graph-based segmentation algorithm. So every distinct color here is one segment of the scan that the algorithm thinks is a thing, right? So our goal is to be able to pinpoint the thing that is actually the brain and not bone, for instance. So the way that we did this was we required that the human actually pick out for one of these images what the brain is. We're not expecting to be able to tell a computer what bird brains look like. And then we traversed, we looked at every single adjacent image, and we ran the same segmenting algorithm, and we looked for a region that looked kind of like the one that the human picked. So here we have an animation that's going from I believe the front of the skull towards the back, going through the brain. On the right are the CT scans. On the left is what the algorithm thinks is the brain. So you can see it's generally good. There's some spots where it gets things wrong. There's some places where it gets things catastrophically wrong, and we've kind of just not put them in this animation. So so there's still some work to be done.
So that was bird brains. So let's look at dinosaur brains, which is that thing you see on the left. So the brain section you'll see is that little highlighted region that you might not be able to see from far away. And so we need to find that with a computer algorithm. On the right is what the computer algorithm found. As you can see, we found a lot of regions all around the brain, but we kind of missed the actual brain. That's because, again, the contrast of the images, because there's no actual tissue, because they're fossils, it's a lot more difficult to work with, as well as there's a lot of sediment that kind of like confuses the computer vision algorithm. But we think that this could be possible with a bit of time and a bit of work. As you can see, we kind of just went around it. And lastly, we did some 3D printing.
So once you've segmented the brain, you have all these nice files saying this is the area where the brain is. You really want to visualize it and actually see what this shape looks like. There's a file format called STL, which defines surfaces, which you can use for 3D printing and 3D modeling and things. It's not the easiest. There aren't a lot of tools out there to build these files easily. We had a couple of approaches. We used ImageJ and kind of built that to take all these stacks of images. And we also wrote a C library with a Python wrapper to take these all these stacked brain images, construct them into this nice 3D surface file, and then you can print it and get a 3D rendering of the brain you just found. And thank you very much.